Good morning, grade 9s, and welcome to lesson number 5. So today we'll be finishing up the section for the week, which is really cool because then we get to go on to acids, bases, and pH levels. So today we're doing rusting. Remember, in yesterday's lesson, we did the first and second half of the section, and now we're doing the middle piece, which is rusting. So rusting is a type of corrosion. Now, corrosion isn't a good thing in any sense. Corrosion means something being broken down. So rusting is a slow chemical reaction of iron with oxygen in the air in the presence of water. So if you have a piece of iron in the open, it's obviously going to be exposed to oxygen because oxygen is in the air. Now you create a moist environment. Let's say it rains constantly, or those little that almost like layer of dew you get on the grass in the morning, that will start the reaction of rusting and corroding. But all metals do not corrode at the same extent. Iron corrodes so fast. It's a rapid corrosion. So a lot of sodium corrodes so fast that it has to be stored in oil. The least reactive metals like gold and platinum do not corrode even after many years. But iron is our most common metal used in our daily lives, and it is quite a fast. It corrodes fast. The formation of rust. This is a chemical reaction with iron and oxygen with the presence of water. So you get an iron oxide, Fe with the little 2, O with the little 3. This oxide is an orange-colored solid that we call rust. You can even scrape it off and you get this almost powdery orange stuff in your hand, and that is rust. So a bicycle made up of iron-based metals will rust faster in Cape Town because it is near the coast. It is more humid than in Johannesburg, where we aren't close to a large body of water. Rusting happens at the surface of iron when it is exposed to air and water for a long time. We can see that corrosion is starting to take place when a metal loses its shine. So when it loses that shine that will blind you when the light shines on it, that's when the rusting has already started. So it may not look that orangey color, but it has actually started. So a red-brown color, this is iron oxide. Rusting is a continuous process, so over time, more and more of the metal turns into rust. After a long time, holes will form because the rust has essentially eaten through the metal. Think of it as like a germ, and all at once, all the germ can live on is this iron. And this little red-brown orangey germ just wants to eat and eat and eat because it's greedy. And then all of a sudden, poof, there's nothing to eat because you've got a hole. All the iron has corroded. So then we have ways to prevent rusting. Iron will rust. There's no way to change iron itself so that it won't rust. So what do we think? What do we do? How do we prevent something from rusting that is prone to it? We cover it up, for instance. If there's a layer between the oxygen and water and the iron, then the chemical reaction can't happen. So we can galvanize the iron. This is when iron is coated with a thin layer of a more reactive metal. This protects the iron, so that metal reacts and corrodes rather than the iron. Then we have chrome plating. It is another way of protecting steel or iron. Electrolysis is used in the process of electroplating. The electrolysis reaction deposits a thin layer of chromium onto the steel. Chromium does not rust. So if we have chromium and then the iron or steel, then there's a layer between the iron and the oxygen and water like we discussed. But that layer doesn't rust. So essentially it will never rust as long as the electroplating lasts. You can also paint iron. That's a very simple one. If there's a layer of paint between your iron and air and oxygen, the chemical reaction can't happen. Sometimes with ships, with their pipelines, because now that's in water constantly and being reactive with oxygen, they put a more corrosive or rusting prone metal next to the pipeline so that the oxygen and that chemical reaction will be predominantly on that one, not and leave the actual pipelines that are working alone. So it's the companion pipeline takes all the weight of the rusting. And lastly, we can avoid rusting by applying a layer of oil. Remember, with our sodium, it corrodes so quickly we have to keep it in oil. So not all metals are like that. Not all metals are so corrosive. So if we put oil, it prevents rust by repelling water. As oil and water do not mix, the water does not come into contact with the metal. We need three things. We need our metal, which is usually iron or steel, oxygen, and water. Without one of those, rusting doesn't happen. So if oil protects the metal from water, we don't have the right ingredients for our chemical reaction. So therefore, rust cannot take place. So that's it for this section. We're going to start topic 8 next week. So I need you to do topic 7 revision on page 98. It's a lot, but I think you guys will handle it perfectly okay. Remember, go back, listen to your videos, read your notes, know exactly what you don't know, because then in our Skype sessions, you can ask and we can sort it out. And if you're perfectly okay, send me pictures or ask me questions and we will sort it out and have the memo sent. So thank you so much, guys. Have an amazing day and work hard.